Namaste students, and welcome back to the Waves Mastery series for JEE Main and Advanced. Today's topic is superposition of waves, the foundation behind interference, beats, standing waves, resonance, basically everything exciting that's coming next. So let's get started with calm minds and sharp focus. First, what exactly is superposition? Listen carefully. This is the heart of wave physics. Whenever two or more waves meet at a point, the resultant displacement at that point is simply the algebraic sum of the individual displacements. Mathematically, we write y resultant is equal to y1 plus y2. This works only for linear media, where displacements are small. Let's consider the most important case first. Two harmonic waves of same frequency traveling in the same direction. Let y1 is equal to a 1 sin and y2 is equal to a 2 sin. Applying superposition, we get y is equal to y1 plus y2. Using the standard trigonometric identity, we get y is equal to a sin, where the resultant amplitude is a is equal to square root of. The resultant is still a simple harmonic wave. Only amplitude and phase change, while frequency and wavelength remain the same. For constructive interference, when phi is equal to 0, the maximum amplitude is Amax is equal to a 1 plus a 2. Waves add in phase. For destructive interference, when phi is equal to pi, the minimum amplitude is a mean is equal to vertical bar A1, A2 vertical bar. Waves oppose each other. If amplitudes are equal, a 1 is equal to a 2 is equal to a, then the resultant amplitude is a is equal to 2 a cos. This formula is extremely important for JEE problems. Remember, energy is not additive like displacement. Energy depends on amplitude squared, E proportional to a squared. In constructive interference, amplitude doubles, so energy becomes 4 times. In destructive interference, amplitude becomes 0, so energy becomes 0 at that point. But total energy of waves is still distributed, not destroyed. In JEE, graphical questions are favorites. Explain two cases. Case A, pulses overlap partially. Resultant equals pointwise addition of displacements. Case B, pulses completely overlap. Peaks and troughs add depending on their signs. Displacements add. Shapes do not change permanently. When two SHMs act in perpendicular directions, they produce Lissajous figures. Let x is equal to a sin and y is equal to b sin. Shapes vary: straight line, ellipse, circle, complex loops. Extremely important for sound waves and oscilloscopes. But we will study full Lissajous patterns in a later episode. JEE PYQ types include: given two SHMs, find the resultant amplitude. Find the condition for constructive or destructive interference. Other types are graphical addition of pulses and resultant intensity from two sources. Intensity relation: I is equal to I1 plus I2 plus 2 SQRT cos phi. This will be used heavily in sound and optics. Now, for a quick summary, we covered the superposition principle, the resultant amplitude formula, conditions for maxima and minima, energy discussion, and graphical superposition. Great work, students. Superposition is the gateway to everything: interference, beats, standing waves, resonance, and even sound wave patterns. In the next episode, we enter the world of interference of waves, visual, conceptual, and extremely scoring in JEE. Stay consistent, stay curious. This is your professor signing off. See you in the next class.